In this video, we'll be learning how to root factor polynomial functions using a few examples. Now let's get started. Let's consider the following polynomial function. F of x equals to 2x cubed plus 12x squared plus 6x minus 20. Now the first thing we'll do to root factor this polynomial is to place the leading term's coefficient, so in this case 2, as a factor. So we'll write f of x equals to 2 times x cubed plus 6x squared plus 3x minus 10. And the reason we do this is because the polynomial that we see in parentheses here will have the same roots as f of x. So rather than working with f of x, we'll be working with the polynomial function x cubed plus 6x squared plus 3x minus 10. Now, the roots of this polynomial, if it has any, will be factors of the constant term at the end here. That's negative 10. So really one of the first things we do is list all the factors of 10, or in this case negative 10. So those factors are plus or minus 1, plus or minus 2, plus or minus 5, and of course plus or minus 10. And now it's really trial and error. Let's just evaluate this polynomial function at these various values, plus or minus 1, plus or minus 2, and so on, and see whether or not it's a root. So let's get started. We'll try first at x equals to negative 1. And we'll evaluate it using the nested scheme. So looking at our polynomial function here, the coefficients are 1, 6, 3, and negative 10. So we make our small table. And so we're evaluating at negative 1. So carrying down the 1. Now, negative 1 times 1 is, of course, negative 1. 6 plus negative 1 is 5. Negative 1 times 5 is negative 5. And 3 plus negative 5 is negative 2. Negative 1 times negative 2 is 2. And negative 10 plus 2 is negative 8. Now, since this is not equal to 0, negative 1 is not a root of this polynomial. So the value negative 1 doesn't work. That's okay, we move on to the next value. We try x equals to 1. And again, we make our small table. The coefficients are 1, 6, 3, and negative 10. And we're evaluating at 1. So we carry down the 1. 1 times 1 is 1. 6 plus 1 is 7. 1 times 7 is 7. 3 plus 7 is 10. 1 times 10 is 10, of course. And negative 10 plus 10 is 0. Now, since we find 0, this means that x equals to 1 is a root. And in turn, this allows us to state that x minus 1 is a factor of this polynomial. And we have our quotient polynomial function here, which I'll call q1 of x. So at this stage, what we can already write is that our polynomial function x cubed plus 6x squared plus 3x minus 10 equals to x minus 1, the factor, times q1 of x, which is x squared plus 7x plus 10. And now we could carry on with this method, but since our q1 of x here is a quadratic polynomial, or a quadratic function, we can just go ahead and factor this the normal way, or the usual way, I should say. For instance, we could go ahead and split the middle term. So if we consider x squared plus 7x plus 10, we're looking for two numbers which add up to give 7, and whose product is 10. And it doesn't take us long before finding that x plus 5 times x plus 2 work, since 5 plus 2 equals to 7, and 5 times 2 equals to 10. So we can go ahead and write x cubed plus 6x squared plus 3x minus 10 equals to x minus 1 times x plus 5 times x plus 2. And we're almost done. Remember, at the very beginning we had placed the leading coefficients, or leading terms coefficient, 2, as a factor. So we have to put that back now for our final answer. And so we can write f of x equals to 2 times x minus 1 times x plus 5 times x plus 2. And we're done. We've just root factored this polynomial. Let's look at another example. Let's consider the following. Say we're given f of x equals to 2x to the power of 4 plus 8x cubed minus 14x squared minus 68x minus 48. And again, we're asked to factorize this polynomial. Well, the first step, remember, is to take the leading term's coefficient and to place that as a factor. So that would be 2 times x to the power of 4 plus 4x cubed minus 7x squared minus 34x minus 24. And we now focus on the polynomial inside these parentheses. Remember, it has the same roots as f of x. So we're focusing on x to the power of 4 plus 4x cubed minus 7x squared minus 34x minus 24. Now, any roots this polynomial may have will be factors of this constant term, negative 24. So we go ahead and list all the factors of negative 24. Those are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and of course plus or minus 24. And now we work our way through this list and trying out each of these elements, or each of these numbers I should say, to determine whether or not they are roots of our polynomial. So let's get started. We'll start with x equals to negative 1. So the polynomial we're dealing with, remember, is this polynomial, and its coefficients are 1, 4, negative 7, negative 34, and negative 24. And we're evaluating it at negative 1. So we start by carrying down the 1. Now, negative 1 times 1 is negative 1. 4 plus negative 1 is 3. Negative 1 times 3 is negative 3. Negative 7 plus negative 3 is negative 10. Negative 1 times negative 10 is 10. Negative 34 plus 10 is negative 24. Negative 1 times negative 24 is 24. And finally, negative 24 plus 24 is 0. So, x equals to minus 1 is a root. And therefore, x plus 1 is a factor. And we have the quotient polynomial here, which we'll call q1 of x. So at this stage we can already write, and I'll write it here on the right hand side, we can already write that x to the power of 4 plus 4x cubed minus 7x squared minus 34x minus 24 equals to x plus 1 times q1 of x, whose coefficients we have listed at the bottom of this table. So that would be x to the power of 3 plus 3x squared minus 10x minus 24. Okay, so now that we've done this, we're no longer going to focus on our initial polynomial function that we had up here. Instead, we'll focus on q1 of x and try and find its roots, since it will have the same roots as f of x. So let's go ahead. We'll carry on with our list of factors, and the next factor will be 1. So our polynomial function, q1 of x, has coefficients 1, 3, -10, and -24. And we start by evaluating this at x equals to 1. So we carry down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. -10 plus 4 is 6. And 1 times 6 is 6, of course. Finally, -24 plus 6 leads us to -18. So x equals to 1 is not a root. So we can just put a little cross there. The next one we try is x equals to -2. So again, we have our coefficients. Those are 1, 3, -10, and -24. And now we're trying to evaluate it at -2. We carry down the 1. -2 times 1 is -2. 3 plus -2 is 1. -2 times 1 is -2. -10 plus -2 is -12. And -2 times -12 is 24. Finally, -24 plus 24 is 0. So, since it's 0, we can say that x equals to -2 is a root. And therefore, x plus 2 is a factor. And we have this quotient polynomial, or rather we have its coefficients right here, and we'll call it q2 of x. So at this stage, we can factor q1 of x and say that x cubed plus 3x squared minus 10x minus 24 equals to x plus 2 times q2 of x, whose coefficients we have listed at the bottom of this table. So those would be x squared plus x minus 12. And now that we have this quadratic, we can factor this, I want to say the usual way. We can, for instance, split the middle term. So we can go right ahead and say that x squared plus x minus 12 equals to, well, let's see, we're looking for two numbers which when added up give us 1, and when multiplied together give us -12. So 4 and -3 work quite nicely. So we can write this equals to x plus 4 times x minus 3. And there you go. We've fully factored everything. So combining all of these results, we can see that we have the factor x plus 1, which we have here. We also have the factor x plus 2. And finally, we have the factors x plus 4 and x minus 3. So going back to our polynomial, we can write that x to the power of 4 plus 4x cubed minus 7x squared minus 34x minus 24 equals to x plus 1 times x plus 2 times x plus 4 times x minus 3. But we're not quite done. Remember, at the very beginning, we had placed 2 as a factor, so we need to add that now and state our final answer, which would be f of x equals to 2 times x plus 1 times x plus 2 times x plus 4 times x minus 3. And we're done. Let's look at one last example. Now, let's say we're given the following. F of x equals to negative 3x to the power of 4 minus 3x cubed minus 6x squared minus 12x plus 24. And again, we need to factorize this polynomial. Well, the first thing we do again is we place the leading term's coefficient, negative 3, as a factor. So we write f of x equals to negative 3 times x to the power 4 plus x cubed plus 2x squared plus 4x minus 8. Now that we've done this, we're going to be focusing on this polynomial, which has the same roots as f of x. So that's x to the power of 4 plus x cubed plus 2x squared plus 4x minus 8. And any roots it has will be factors of negative 8. So the first thing we do is we list all of the factors of negative 8. Those are plus or minus 1, plus or minus 2, plus or minus 4, and of course, plus or minus 8. So let's get started and see whether or not any of these factors are in fact roots of this polynomial. So we'll start with negative 1. So the polynomial we're focusing on, remember, is this one, and its coefficients are 1, 1, 2, 4, negative 8. And so using the nested scheme, we make our table, and we're evaluating at negative 1. We carry down the 1. Negative 1 times 1 is negative 1. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 2 plus 0 is 2. Negative 1 times 2 is negative 2. 4 plus negative 2 is 2. Negative 1 times 2 is negative 2. And finally, negative 8 plus negative 2 is negative 10. And since this is not equal to 0, this is not a root. Okay, so let's move on to the next. We try x equals to 1. Now, starting over with our coefficients, those were 1, 1, 2, 4, and negative 8. And at x equals to 1. So we carry down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. 2 plus 2 is 4. 1 times 4 is 4. 4 plus 4 is 8. 1 times 8 is 8. And finally, negative 8 plus 8 is 0. And since we find 0, we can state that x equals to 1 is a root. And therefore, x minus 1 is a factor. And we have the coefficients right here, and we'll call it q1 of x. So at this stage, we can write that x to the power of 4 plus x cubed plus 2x squared plus 4x minus 8 equals to x minus 1 times q1 of x. And using the coefficients we have there, we can say that it's x cubed plus 2x squared plus 4x plus 8. We now focus on q1 of x, which I'm underlining, and we're going to carry on trying out these different factors of negative 8. So the next one would be negative 2. So remember, we're working with this polynomial q1 of x. Its coefficients are 1, 2, 4, and 8. So carrying down the 1, negative 2 times 1 is negative 2. 2 plus negative 2 is 0. Negative 2 times 0 is 0. 4 plus 0 is 4. And negative 2 times 4 is negative 8. Finally, 8 plus negative 8 is 0. And since we find 0, we can state that x equals to minus 2 is a root, and therefore x plus 2 is a factor. And we have our second quotient polynomial, which I'll call q2 of x. Its coefficients are 1, 0, 4. So using this result, we can write that q1 of x, which was x cubed plus 2x squared plus 4x plus 8, equals to x plus 2 times q2 of x, which is x squared plus 4. Now our last step really is to factor this polynomial q2 of x, which I've just underlined. But now we can see right away that x squared plus 4 doesn't have any roots, since indeed x squared plus 4 equals 0 has no real solutions. What this means is that we stop here, and in fact our job's done. We can go back to our original polynomial up here and state that x to the power 4 plus x cubed plus 2x squared plus 4x minus 8 equals to the different factors we found, which were x minus 1 and x plus 2, so those are x minus 1 times x plus 2 times x squared plus 4. And we cannot go any further within the set of real numbers. Finally, we go back to the very beginning and remember that we had placed negative 3 as a factor. So we state our final answer, which is f of x equals to negative 3 times x minus 1 times x plus 2 times x squared plus 4. And there we go. That's how we root factor polynomials.